When a non-compressible fluid, so this fluid inside this container is non-compressible, is flowing through a container. When this fluid flows from the area of the container that is large, so I'm going to call this over here A1, and this to a smaller cross-sectional area A2, the volume of the fluid that flows from one point to another has to remain constant. That's sort of like a rule for non-compressible fluids. The volume of fluid, volume flow rate is constant. What's a rate? Something per time? So if the volume flow rate is constant, then that means that the volume per time in one section of the pipe should be equal to the volume per time in the other section of the pipe. Now, if you think about it, the volume of fluid that's passing through maybe this piece right here, I want to shade it in, highlight it there, that volume of fluid would just look different over here. To have that same volume, maybe it's this whole length there. So this area is passing through this distance x1, this distance x2, and since volume is area times length, like volume of a cylinder is area times length, then that would be A1V1 over T is equal to A2V2 over T. What am I doing? I got all excited about the velocity. That should be an x1 and an x2. Oops. Over T. There you go. Now, what is x over T? What are the units? Meters per second? And meters per second is the unit for velocity. So now I can write my A1V1 is equal to A2V2, which is the volume per time. It is the volume per time. That looks ugly. So this is your continuity equation.